Hey everyone, welcome to this video, this long-awaited video. This week we're talking about GraphQL. Now, if you don't already know, GraphQL is a API kind of like alternative to REST. And as you know, we've kind of talked quite a lot on this channel about how to hack APIs, how to get started with APIs, how to find bugs in them, etc. So this week we're going to talk about GraphQL because GraphQL works very differently to REST, and because it works very differently, you have to kind of approach it in a different way. Now, once again, this video is very, very kindly sponsored by Integrity. You know, they've been such a good friend to this channel. We've just got to give them a lot of love. It's a bug bounty platform like HackerOne and BugCrowd. It's smaller and focuses on European customers. They're huge supporters of the bug bounty community, sponsoring not just my content, but other creators too, and I'm really happy to work with them. I know a lot of people have already signed up, and even some people find their first bug, they've got Red Bull, or they've participated in some of the XSS challenges, and I've actually seen some discussion about the XSS challenges on my Discord, and I'm really happy for everyone for really getting started. If you would also like to sign up, you can sign up with my link on screen. go.integrity.com/Katie. You don't need to be European, they just have European customers. That's go.integrity.com/Katie. It's on the screen, it's in the video description. Let's start with kind of a big question. What is GraphQL? And I've talked a lot about it, like I've talked about it in maybe all of my API hacking videos. But I've never really talked about what it is and kind of just assumed people would go and Google it. But now it's time to break that down. So what is GraphQL? What is it exactly? It's an API, kind of. It's an API, but not as we know it. Usually when developers write an API, they actually end up writing quite a lot of endpoints. And as we know from, talking about recon, that actually makes it really difficult to do recon on, because you might have hundreds of endpoints you need to find during your recon activities, especially for a larger API. And actually, when it comes to like the development side of things, developers have hundreds of these API endpoints to write. So what it ends up being is quite a lot of development effort to try and make all these API endpoints. So instead of having like all these endpoints, one for every CRUD operation, and then for each resource, one for every CRUD operation, you end up with hundreds of one. It goes insane very, very quickly. But it's special because we only use one endpoint for every resource in our database. So why one endpoint? Well, I kind of said, it makes things on the dev side really quicker to make. Instead of making like tons of these endpoints, they write queries instead for common operations. And then they can reuse these queries a lot more easily than you can kind of reuse RESTful API endpoints. And you'll see this come into play, especially in a little while when we start talking about how actually this works in practice. We'll see how these how these queries are structured and what makes them so great. Although they're very different from SQL queries, if you are already familiar with SQL, in the sense that you can return, any endpoint, any field you want. You can have operations on the fields. In the style, they're very similar in that way, but actually the syntax is really different. And the syntax is, I promise, the hardest part about GraphQL. Like, the actual hacking of it, easy. I promise you, not that hard. There's no really weird bugs. But the syntax can really trip people up. But let's talk about why hunt for bugs in GraphQL? And really this kind of boils down to this one point, which is it's a newer technology. Because it's newer, developers may be adopting it without really fully being aware of the security concerns, which is not great for their users, but as bug hunters, that's kind of good news for us. But like I said, it's intimidating. It looks scary, it looks really difficult, but actually, it's not as hard as it looks. And once you tend to kind of understand the syntax and practice a little bit, you'll find that actually it may even be easier for you to hack rather than a traditional API. Especially for people who have like a programming background. I think people with that kind of background will find this a little bit easier to learn. But honestly, it is not that difficult to just learn it from scratch. I promise. And in fact, one of the other reasons why it's a lot easier is because you don't necessarily have to do recon. In quite a lot of cases, not in every case, but in quite a lot of cases, you don't actually have to do any recon. So if you don't like recon like me, you might find GraphQL is kind of awesome. And I want to take this time to kind of tell a quick story. I don't really tell a lot of stories. But when I was going to my second ever live hacking event, one of the companies there used GraphQL, and I had only done the Hacker 101 GraphQL levels a week or so prior, maybe 2 weeks before the event. And that's all the knowledge I knew, is that just completing those kind of really quite simple levels. And at that event, I found 2 bugs specifically because I wasn't intimidated by GraphQL. They weren't GraphQL specific bugs. They were very much a case of, I understand how I'm going to approach this problem, therefore I can hunt for bugs. So when it comes to kind of why do it, I think there's a lot of bugs there that actually, even if you're a beginner like me, these are only my 3rd and 4th bugs, right? I really was not that much of a bug hunter at the time. But for me, I could kind of, I'm not going to say the word easily, but kind of quite straightforwardly find bugs in it. So I'm a big fan of, finding your first bug, or maybe finding, when you're a newbie starting out with something like GraphQL, which is quite easy to pick up. But anyway, sorry, story time is over. Where do you find GraphQL? Where should we actually be looking for? And this is going to be kind of a theme throughout this video. The same place you find other APIs. GraphQL isn't some kind of magic technology which only the most elite companies use. It's just the same as a RESTful API. It's used in the same kind of places, though it does tend to be more common with newer applications. But you've got Yahoo, Shopify, HackerOne, all use GraphQL. Some of the big public programs on HackerOne, they're using GraphQL, and it's fairly common. If you've got maybe a target you're working on, maybe you're working on one of those, you find GraphQL is usually located at kind of specific endpoints. I've seen GQL. Sometimes you see GraphQL, sometimes you see graphical, which is just a user interface. GraphQL/console, graphical/console. All of those kind of GraphQL endpoints we'll actually see later on, but there are word lists that will just list a bunch of GraphQL endpoints that you can run. But yeah, if you think you found something or you're not really sure, you can look out for words like in requests and responses referencing queries, mutations, subscriptions. These are quite GraphQL specific. Sometimes you might see data in responses as well. So they can be a good way to kind of find it, especially if you end up with an endpoint that's just Q as a parameter and then the query, and then it just goes off to a random domain, which is where I found one of my bugs. But yeah, so honestly, that bit is probably the only thing that's different. It tends to be in the same place you find regular APIs, mobile apps, web apps, anything where you tend to find, both of those doing the same thing. Mobile apps especially tend to kind of go more towards it. But yeah, that's where you find it. So hopefully I've convinced you, but let's talk a bit about how GraphQL works, because it's really important to understand why developers want to use GraphQL, to understand how we as hackers can hack it. So the very first and most important part of GraphQL is that it implements a graph structure in the database. Then on that, we have queries and mutations. Now these are written by the developers ahead of time. Queries fetch data, Mutations allows the data to be edited, and that's really important because it comes up later when we start talking about tooling. These are two different ideas between a query and a mutation. Then we have fragments, which allows for these kind of saved lists of fields, and meta fields, which allow for the inspection of a query or mutation and the information within that. So, okay, let's go a bit more into detail though. So first, let's talk about graph structure. Now, usually, and if you've ever done computer science, you'll know this, we represent data as tables. We kind of, if you've not seen data represented in this way, it kind of looks like a spreadsheet, which means it's two-dimensional, right? You have rows and you have columns, and you have, for each kind of piece of data you have, you know, your ID, your name, your email, what have you, that's on one row. And then each one of those kind of name, email, username, password, whatever, then goes on the columns. Now, one thing that kind of happens when you have this structure, especially in modern web apps, you need more from it, because you don't just have like standard usernames anymore, because users sign up to something and then they do something to a web page, right? So you don't just have users on their own, you have users which, let's say on YouTube, you can write a comment, you can watch a video, and those are all actions that are associated with your user. Now, what we usually do as kind of programmers, when I say we here, what programmers usually do is you link these two tables together using IDs. So for every video uploaded, there'll be some kind of user ID which represents the author of the video. For every comment, there'll be the comment author. And then a video ID that represents the ID of the video. And that's the only way we can represent this structure of how the real world probably actually works in our kind of flat databases. Now, a lot of people still think about it in these flat databases, and there's nothing wrong with that. That is a lot of developers, a lot of software is written that way. But actually, when we think about it and start to draw this out, the kind of natural form ends up being this graph. So if I just show you here, pointer options, pen. So we have a book called The Economics of Inequality. We know that that has an author, which is Thomas here. And actually, we know that the same author also authored Capital. But his co-author, Arthur here, didn't author The Economics of Inequality. There's no relationship between those two, but there is a relationship here. And you can see when we kind of describe this, so if you think about literally these two books, you have book 1, Economics of Inequality, author is Thomas. You have book 2, Capital, the author is Thomas and Arthur. And what this kind of makes it easy to do is get all the books that Thomas has authored or has co-authored. And it makes it easy to get who his co-authors are. It makes it easy to get, you know, from one book, every single author. This is just with two entities though. You can imagine if you think about something bigger. Like, let's think about something like YouTube, where you have videos and comments and users and thumbnails, and you have the analytics associated with each video, and you have community posts, and they have comments, and then you have stories, and you can kind of see how, you know, if you want to get one user, maybe you want to grab every single video they've uploaded, every single comment they've made, etc., and show that. And that's really where a graph structure can be a huge help in helping developers kind of realize their data. Now, realize as in make real, not to realize that they have data. You'd hope they'd know that by now. So, queries. Queries in GraphQL are written to be really flexible. You can request any field easily, including related entities on a graph. So here you can see we've made a query here for the hero. Now, this is a query that the developer has written ahead of time and has done some kind of linking to the database already. So this is written in kind of code, and they define it as hero. Now here, where name is, this is where we can specify what field we want to return. And you can see on this side, where we comes back here in data in this JSON, we can see that we've got hero and then name represented here. But actually, A hero might have loads more other ones. You could probably put in whatever you wanted. You could start to specify, you know, in this case, this is Star Wars characters, what films they've been in. You might specify how long they've been on screen for. You might specify the actor that plays them, etc., etc. And now, what is really interesting is that you can associate it with other entities. Now, you know how we're talking about the graph here, and we might look at this author, Thomas, and we might want to get from that the economics of inequality and capital. We want to do a kind of get both at once. We can do that here. So here you can see we've got this friends array, and we're returning whatever data we want from friends. Now, note here that we're returning name. We could return anything again. All we need to do is just reflect it in this part here. And this is what I mean when I say the syntax of GraphQL is often the hardest part. And working out what you want to get from a query can be really difficult. But this isn't all I can do, right? So you can return one result or several results. You can include arguments. So in this one, we're getting specifically the human with the ID of 1,000. And then you can see we specified an additional parameter here, height. So our height is then here. Now, this is only just limited because, in this case, hero can be a type of human. You could also get height in this query as well. Now, okay, what else can you do? Well, you can also do data manipulation. Here we can provide yet another argument for a unit, and we can change the height from being in meters to being in feet. And this is where GraphQL really shines for developers. Because for a developer, what that means is one API endpoint that we just change one argument on, and then we can make our America version and the rest of the world version when we swap between feet and meters. It means that if we write an API endpoint and go, ooh, I've forgotten to write blah, like I've forgotten to put the height in that, we can just change one line, not write another query potentially. And as you can see from this, it's very structured. So queries always start with these kind of opening brackets and closing brackets. And then in here, we then have the name of the query, which is hero. And then we have inside that what parameters we want to grab. And here inside, if we want to kind of do these associated entities, we can then have our same fields in here as well. So it's quite structured. If you're hacking with this, you do need to make sure that all of this is URL encoded. Very easy way to get tripped up is to forget that essentially, as far as GraphQL is concerned, these are strings, not like JSON data, although it returns JSON data. So that's queries. Let's talk about mutations. Now, while queries fetch data, a mutation edits it. And it's really important to keep that in mind because often in quite a lot of GraphQL tools, you'll see these separated, even though we might think they're quite close to one another. Now, this might be literally editing data, it can be deleting data, it can be creating new data. This is just modifying data. And we can also fetch it afterwards. So here we've got our query again, so create review. And this part here, this is a variable. So we can also include variables from this part here. And as you can see, we're putting in ep is Jedi, and then review goes here. But this could quite easily be another object, right? This can all be done in line. All it's doing is just doing a find and replace. So here we can see in this mutation, we've got the create review, that's our function. Then we've got these, parameters, and then we're putting into the parameters these variables. And it's, again, quite straightforward. You could replace this kind of $ep with, you know, this literal string here. Again, has to be URL encoded. Do keep that in mind. This, when we're actually hacking, this all needs to be URL encoded, otherwise it's just going to break. So from that, we can also fetch the data afterwards. So we're creating the review here, and then from that, we're fetching the stars and the commentary. So really, really nice, very nice structure here. But it does take some getting used to, especially when you're writing stuff yourself. I really recommend the Hacker 101 GraphQL levels, because they're a really great introduction to getting used to writing queries and mutations that doesn't overwhelm you completely, because quite a lot of the conversation around GraphQL tends to be more focused towards developers rather than towards the security concerns. Although there are really nice tools for it, it tends to be for developers more so than for security people. So just bear that in mind. So then you've got fragments and meta queries. Now, one of the really nice things about GraphQL, and what kind of separates it from everything else, is how flexible it can be for developers. So a fragment allows you to decide a list of fields and use that in multiple places. So here we can see these are the fields we want each hero to return. And if we look over here, we can see that our left comparison here has all of these fields. Now, if this had scrolled down, we would have seen the right comparison will also have all those fields. And, well, you're probably thinking, okay, but what does that mean? That means that we could create really complex queries fairly easily, especially if we want to compare two pieces of data together. GraphQL makes it really flexible to do that. And then the next point here is that meta fields allow you to inspect the API. So for example, -- type name returns the name of the type. And these two concepts, the idea that you can not just query the data, but the actual database itself, the schema, the kind of underlying structure, make it possible to do something called introspection. And that is an extremely important concept, because how are you supposed to know what's in the database? How do you know what queries developers have written, what mutations exist, what the arguments are, what fields you can return, what their types are, what you can request? Now, I'm glad you asked, and you're probably asking those questions, because let's talk about how fragments and meta queries come together to produce something called introspection. And to answer the question, how do you find all of those queries and mutations? Now, I'm going to start with one kind of main idea here. Now, GraphQL is only challenging to do bug hunting on because of its syntax. It's not because it's full of really hard bugs or the bugs are really difficult. It is just the syntax. So it's really important to understand how queries and mutations are written and how concepts like meta-queries and fragments come together to make recon really easy. And GraphQL can be one of the easiest APIs to actually do recon on because of a concept called introspection. Now, introspection is this. You can see here we've got like type, so references to those meta types. We've got references to fragments, references to the schema, and all this kind of stuff. Now, introspection is this feature of GraphQL. I'm going to make it really clear this is a feature. Introspection on its own is not considered a security vulnerability, usually in most circumstances. And that's because GraphQL, this is by design. We want to be able to do this. We want to return all of this data because it makes developing for it really easy. And so, again, it uses fragments and meta queries to kind of build up this returns, again, JSON, which tells us everything in the database. A GraphQL API can tell us about its queries, and this makes recon a breeze, but we need to be able to interpret the results. So I'm going to introduce you to my favorite tool. I've actually got a whole section on tools, but this is my favourite tool. And this is a tool called GraphQL Voyager. And what it does is it visualizes the output of GraphQL introspection. So as you can see, this is what it looks like. Usually it gets you get it back as JSON, and then you can interpret it, but you can just pop that into GraphQL Voyager and it will show you this kind of graph. So this root here tells you all the queries that can go on the database at the moment, and it shows you how they link together. So here we can see we've got a reference to a species type, a planet type, person, over here, starship and film. So what we can see from like this root thing here, it's not necessarily clear if I just zoom in a little bit. We can see we've got a reference to all films and film, which then link to this kind of structure over here. Let me just change this out for a laser pointer. So you can see we have all films and film, which link to both. You can't really see it, but the line goes kind of like that. That go to this film data type, which we can see has a title, which is a string, an episode ID, which is an int. But if we look down here, you can see we have links then to things like species, starship, vehicle, person, planet, what have you. Now, if we look to what will be on the side, we can see the argument. So we can see all films here doesn't have any arguments, but film can use an ID and a film ID. The same for person is ID and person ID, and what have you. So if we then drill down, we can see a single film has the title, which is a string, an episode ID, opening crawl, director, producers, whatever, which then lets us create this query where we say, okay, we're doing a query called Q1, and we're going to do all films. So we're going through this one here. In that, we can have a data called films. From that takes us into a single film. Then we've got the title. Then we could go into a connection, get the species, and then get the name and the language. So we can kind of go down and build up this quite complex kind of web here. And here you can see it over here as well. So we have the return result here is data, all films. So for every film we have the title. Then we have the connection to species, which then gives us the species, human, language, galactic, basic, which comes in over here. Now I realise this is quite complex and I'm going through it quite quickly. And that's not because I'm trying to punish you, but I think this is best learned and it will make more sense when you try it out for yourself, because it does come pretty easily once you've had that practice. So, okay, that is for queries, but what about mutations? Now, in GraphQL Voyager at the bottom, very easy to miss, is queries here. So we have query root, which is our queries, and then mutation, which shows us our mutations. So from that, we can get to here and see a whole bunch of mutations. This is actually from Shopify. Where you can see checkout attributes update, checkout complete free, checkout complete with credit card, checkout complete with tokenized payment, which then gives us the payloads we need. Now we can go through that again and look and see, okay, what do we need to send? Now, okay, why does that kind of matter? Well, let's say we're buying something on Shopify and we go through the payment. Could we potentially send our request through checkout complete free instead of complete with credit card in order to bypass that step? You know, our business logic error, our little bypass here. Or is it possible to say check out and update it while the credit card is still going through, but still have the checkout update, getting something for free? So we're looking at kind of race conditions. Is it possible to look at, you know, customer access token? Can we create tokens for any user? And then down here we have customer address update, customer address delete, customer address create. Can we like look at IDORs then? And you can see there's actually quite a lot of individual bugs that you're probably already familiar with if you've seen my videos. that actually GraphQL makes it easy for us to say, okay, I can go look at that, and I can go through that, and we can go through these endpoints methodically. What bugs are there likely to be? Well, how do I kind of approach this? Okay, so what's next? What we do from here is we know all the endpoints. We don't have to do any recon. We can just go straight to the API hacking. Now, I said this before, but I do want to make it really clear. Introspection itself is not usually considered a bug. It's usually considered documentation, because quite a lot of the time the people using GraphQL are usually developers, whether internal or not. Now, it can be a bug under some circumstances if there are internal methods being shown there. It might be considered information disclosure. However, just be aware, don't get too excited if it just introspects, it just shows you all of the data back. It may not be a bug at the end of the day. Now, okay, if that's not a bug, what do we really have? Well, we can test all of the queries for information disclosure. We can test all of the mutations for IDORs. We can test for business logic. We can test just like we test a regular API, just like we look for regular bugs. But okay, if introspection is been disabled, what's our approach going to be? Well, we can just use traditional recon. At the end of the day, RESTful APIs don't have documentation included all the time, and sometimes you don't see everything. Click every button. Find out if there's a structure of query names or mutation names. Replace entity names. If you see user create, user update, user delete, well, you can go, well, maybe, post create, post update, post delete also exist. Test for visible GQL endpoints. Just see if you hit a button and see what that calls, and just test those. Keep an eye out for any documentation. It might just list GraphQL endpoints. If you have an error, GraphQL might just tell you what you messed up. You misspelled return all the information from the database when you typed in info, right? So sometimes errors can be quite useful for finding out GraphQL bugs. Now, let's have a quick chat about tools. So there are some tools which are unique to GraphQL, and I just wanted to give a quick list here. The first one is GraphQL IDE, which is a GraphQL IDE integrated developer environment. So it kind of gives you a place to write all your queries and send them. It's fairly easy to use. You're still going to be writing queries by hand, but when you're in the exploitation stage, this can be a really great kind of thing to have a play around and use. And Altair, same kind of idea. A similar in kind of style to the Postman interface. So if you're more used to Postman, you might find that Altair works quite nicely for you. You're still going to be writing handwriting queries, right? But it's the same kind of thing. And again, you can quite easily see what you're posting to and what you're getting. We have InQL, which is a burp add-on, which if you're more used to kind of a burp workflow, this might work quite nicely for you. So you can send an introspection query, and then it will show in this kind of burp interface all of the queries and all of the mutations. It integrates with burp, sends stuff to repeater. If you already use quite a lot of tools in burp and you're quite confident in it, you probably want to just use this because, you can just use burp as you already do it. And you can also generate documentation for it. If you don't really like how GraphQL Voyager looks, then this might be better suited for you. GraphQL Map. Again, this is same kind of idea as InQL, but this one is a command line tool. So it's for introspection and querying. If you're more of a command line user, you already have quite a lot of your tools for the command line, you might find that this suits you a bit better, especially if you're already automating things. You can send queries and mutations, but not just that, you can also generate NoSQL and SQL injection payloads quite easily for GraphQL. So if you do want to do an injection test, again, common API bug, it's worth checking it out. And then GraphQL Path enum. Now, because of the way GraphQL works and these kind of how complex these graphs get and how interconnected they are, it can kind of be difficult, especially if you're dealing with something large like Spotify or HackerOne, how the data actually gets from one node to another, because there's quite a lot of ways of getting to two different places. In the example here, we look at getting from skill to skill from query, and showing how you can go from query assignable items to audit log items to audit log item to pen tester profile, and go on and on and on. So you can kind of see how you might get from these two different two different nodes, how kind of everything's all put together. And this can really help when you start to be a bit more confident in using GraphQL and hacking GraphQL. And it's written in Rust. So you can kind of see it walks through the graph to show you how it's possible. But yeah, so those are some of the GraphQL tools. There's not too much out there. If you want to make some GraphQL tools, I think you probably have quite a good captive audience. Because there's not many people actually hacking on it. And there's not a lot of tools because no one's hacking on it. So let's talk about bugs in the wild. So we understand what GraphQL is. We've got our introspection, we've done our recon, we've got our tools ready. What are we actually going to look for? What bugs are out there? And, the common GraphQL bugs, the same as API bugs. I made this video on the top 10 API bugs and where to find them, which is the OWASP API project. All of those bugs can be found in GraphQL APIs. There's nothing different. If you're newer, I would suggest looking for the usual suspects. Information disclosure, IDORs, bypassing client restrictions. The only thing that makes GraphQL special, the syntax. The bugs are the same, and I'm going to keep on saying that so everyone knows. The syntax is the hard part. Once you've got the syntax down, you've got these bugs down, okay? Don't worry. So let's have a chat. A staff member with no permissions can edit a store customer email. So this was an undocumented GraphQL endpoint. In this case, they found them via, I think, introspection. But it wasn't really listed how it worked. So all they had was the introspection results. And what this endpoint allowed them to do was to change a store's customer email. So that's the email people see when they email a store. Now, what we could do is, it's a simple IDOR. You could do it without being logged in as a staff member. Without the permission, sorry. And the impact really is talking about reputational impact. If you could change the customer-facing email address to something rude, that's going to be a reputational loss for not just Spotify, but really for Spotify's customer their client. And it's a really simple IDOR. There's nothing really special about that. It was one query that they put the right parameters in, and they weren't logged in for. And that's it. That's all that was that's all it took for them to be able to get $1,500 from, right? Really straightforward IDOR. Another Shopify here, which is find all subdomains the bug is verify.shopifycloud.com. GraphQL discloses internal beer consumption, $802. This is quite an amusing one, which was they found all the subdomains of shopifycloud.com and sent out a random query to all of those to figure out which ones had GraphQL endpoints. And again, what they did was another introspection to see what all the queries were, which returned this graph. I've got a link to this, so if you do want to see this graph, you can see it. It doesn't use GraphQL Voyager, it's a different tool. And from that, they realised it includes references to beer. And then they sent those crafted queries to see what endpoints could be run, what queries can be run on the endpoint. And find out what it's possible to discover. And then realise this should be internal only. And show office beer consumption. And again, very simple information disclosure. When we break it down, it's subdomain, find out what subdomains are out there, see if they have a GraphQL endpoint, introspect the GraphQL endpoint, do some kind of crafted queries to understand it. And this is what it was ended up powering, is these screens. I think it's like their own little pubs. You could pull that down to get beer out of them. And then this would then show them whether or not they need to kind of refill the beer. But I thought that was a really fun kind of bug. But let's look at some, again, a very simple information disclosure here, which is $1,000. By querying the GraphQL API with this one line query, right? This is not a complex query. They realized it was possible to have some information about an internal activity on a HackerOne report by realizing that the latest activity ID and latest activity @ return some information on internal comments. In this case, it was on your HackerOne report. You could use this API endpoint to see, oh, there was last activity a day ago, so they must have been looking at it a day ago and put some kind of internal comment on it. And that's what then comes up with the information disclosure. And it's really simple, like it's not complex. These are very, very simple bugs. These are not difficult. And this kind of links in with business logic errors, because with business logic, we're looking at ways of abusing how the application already works to have a security impact. So information disclosure mix a little bit of business logic. Activity of a private program visible to a banned user if he gets invited to a program by Hackbot, $500. So a user was banned from a HackerOne program, and he was able to get re-invited by Hackbot, which is a type of HackerOne automation. So although he couldn't see anything on the web, so it just showed page not found error, if he queried the API, he'd be able to bypass his ban and see information about a program by querying it directly. It's bypassing this client-side restriction, but on the server, the restrictions weren't implemented. And this is when we start to talk about bypassing client-side restrictions, right? It's not necessarily always going to be XSS. Sometimes it's getting past kind of page not found errors using the API. And another very simple information disclosure. In this case, we have information disclosure / IDOR. One of these queries that this person found didn't have any auth methods. So it would return payment transactions to anyone when it should have just been able to be returned by team members. It's not the case that we have complex bugs. They're very simple bugs, but nobody's hacking on GraphQL, so no one's finding all these very simple bugs. And again, I've only picked for this 2 programs. All of these have been HackerOne or Shopify, right? And this was a year ago that there was one endpoint that would just show all of the transactions a program has made to hackers. So we kind of think, like you might think that GraphQL is like, oh, it's too complex, it's too hard for me, or all the bugs are already gone. GraphQL is one of those where the bugs are likely not all gone, and it's not that difficult. It's challenging to get the syntax right, but actually for the hacking, it's quite straightforward. So what about GraphQL specific bugs? Now, GraphQL is quite complex. Here is an example of kind of some of the underlying architecture on the left there. And because of how GraphQL is built, there are some bugs that are unique to GraphQL. And this primarily resolves around kind of how queries have been written in the code. And they usually require access to the source code and some skills in source code review, which, by the way, due to popular demand, I will be covering source code review in the future. So here we have insufficient type check leading to developer ability to delete product repository and group, $5,000. So the API was designed to check whether or not the user had permission to do something to the GraphQL and then let them do that. Very, very straightforward. However, because of the way that GraphQL worked, what you were able to do was essentially send the wrong type of object that you did have permission to edit, and then kind of further along the pipeline, it would resolve into the right type. Now, it wouldn't check for permission when it resolved it to the right type. It would check permission at the start. So essentially this was like a big bypass of a few, actually, not just this one, but there was the other bug they've got written down, which I'll make sure to include in the comments. But you could do quite a lot with this kind of bug. Definitely more on the complex side. You know, this person has dug into the source code to find this and then realized what they could do. So I'm going to link that down below. Highly recommend reading it, but this is the minority of GraphQL bugs, not the majority. And another quite complex one, but also quite straightforward, is NoSQL injection. I'll leave this one as a bit of further reading, but I just wanted to kind of confirm that even classic injection vulnerabilities, NoSQL, SQL injection, are possible in GraphQL as well. This is a great write-up. So, how to hack GraphQL APIs, a simple guide. So really, what I want to share is what your approach should be. Now, step one is to try and introspect to see what queries are there and what mutations are there. If you can't do that, go for a traditional recon approach, push buttons, use word lists. Asset Note recently, I think last week or the week before, released all of their word lists, and that is just gold for getting started. Identify the business logic for each endpoint. So we have these like queries. What we want to know from that is what that query is actually powering. You know, powering the checkout, or is it powering user data, or is it powering X or Y? Then we want to craft our queries. We want to check for our usual suspects. We're not trying to do anything complex here. Information disclosure, IDORs. Go through it one at a time and see what's possible. Half of bug hunting in this way is not being super smart, super clever, being a security genius. It's about being consistent and trying. And the hard part of GraphQL bug hunting is the syntax. You need to practice the syntax. So great place to practice is the Hacker 101 CTF. And in the next few weeks, I'll be doing a live demo to demonstrate how this is done. So next time we'll be covering how to put all of this theory into practice. I'll go over the common vulnerabilities again, and how you use some of these tools and demo this in practice, because this video is already being quite long. And we'll go from recon to exploit, which I'll show you the whole thing. So thank you very much for watching, everybody. I hope that this has got you maybe excited to do some GraphQL hacking. I'm a big fan of GraphQL hacking. You know I like API hacking, but GraphQL especially is one of my favorite things to do because I don't like doing recon and it scares me, and this makes it so much easier. So I really hope that this video has helped you folks out and helped you realize what kind of maybe you want to give it a go. Let me know. And especially if you find any bugs, let me know. So again, thank you very much to our sponsor of this video, Integrity. I really don't take having an advertiser lightly on my channel. I really do genuinely think they do amazing things for the community. It allows me to make serious investments in my channel. One of those has been improving the audio and video editing. They really do interact with their community, and I saw that just this week where one of my viewers had a question and Integrity stepped in and answered it for them. So they're really active in the community. They're replying to people who need help. So please do give them a lot of love. You can sign up with my link on screen, go.integrity.com/Katie. It's on the screen now. It's in the video description. And thank you very much to Integrity for sponsoring my content. I now need to thank everybody who is a channel director of me on Patreon. Yagami Panda, Niklas, Penny, Wardell Castles, Strongbeard, Gynvael, Ram, and James Clee. Thank you very much to my top tier Patreon supporters for being amazing part of this channel and really letting me kind of have a lot more freedom when it comes to what content I make. I really do appreciate it. And I appreciate everyone who watches my videos. So thank you very much, everybody. I will see you on the next one. Bye, everyone.